Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Hi everyone, welcome to this episode of Speaking Reliability. This is Chris Jackson.
And this is Fred Trinkler. Hey, Chris, good to talk to you again.
Mm-hmm. And we're going to talk about RAMS Europe next year, the Reliability Maintainability Symposium. It's going to be held in June in Norway.
Yeah. In Norway or Sweden? Norway. You're
No,
right.
Norway.
Norway,
At
yeah.
Trondheim, Norway, June 24th to 25th. So it's only a 2-day symposium, not conference. It's obviously the cousin, brother, sister, nephew,
Spin-off.
whatever you want to call it, to Rams US. It's actually quite different, to be clear. But yeah, it's just starting up, and I was there last year, and yeah, with any luck, you can get a fairly decent footprint going on over in Europe, where I think there always needs to be more areas for discussion, and actually argue many existing reliability and asset management and maintainability and quality conferences are a little bit stuck in their ways, and I think this is a really good opportunity for those people who are in Europe and the United Kingdom, used to be Europe, part of the European Union, I should say. But I think it's a good opportunity for people to get involved, organizations and companies to get involved and really shape how a brand new symposium grows and evolves, and perhaps in a way that other established ones can't.
Yeah. And a really good way to get involved is write a paper for it. And the
Right.
call for papers I saw came out just recently. And I believe its deadline is January, the end of the month in January 30th, 31st, somewhere in there. So you got 6 weeks lead time to get your call for papers in there and work from the inside then to help shape what they talk about by having a paper there.
Absolutely, and it's good. There's not a lot of fat right now, obviously, but I think one of the good ways to learn about RAMs and reliability and maintainability is to stand in front of people and try to teach them about RAMs, because you need to be on top of your game yourself. So I think you'll agree, for one of the best ways to learn.
Yeah, it's an old adage, isn't it, Chris? The best way to learn something is to teach it.
Right.
You have to pay attention. You got to get your act together and all those good things. But no, it's a good idea. But that's not why we're here to talk about that. That was not a sponsored placement or ad or anything else. I think Chris and I both agree that this new initiative is well worth it. So we want to give it a shout out. But you also talked briefly about, before we hit record, about upcoming article you wanted to write, which was too long for a title for a podcast, but I summarized it to build, test, fix.
Right. So yeah, and I think I was having a conversation with a client, and I reworded build, test, fix as a scenario where essentially you assume everything works until testing tells you it doesn't. And if anyone could challenge that definition or that interpretation of build, test, fix, I am all ears. Because I think a lot of testing has a very awful cultural impact, in that it essentially puts a lot of brains into neutral, because when you see in your schedule or your calendar that reliability testing will happen in March or whatever the date is, I've never seen an organization where someone's brain doesn't just switch off, because that's when reliability gets done.
Your thinking is that we don't have to worry about reliability because they're going to test it later.
Right. Or even not going that far. It's just simply saying, well, that's when the reliability stuff's going to happen. It's going to happen there.
Yeah. And I rankle with that, and I've run into plenty of people like you have that opinion of it. Is reliability happens with every decision you use to make the design, to create the product, to create the service or whatever. that's where reliability of your eventual service or product actually is created. And it's not
Right.
testing. Testing has got nothing to do in too many cases of improving reliability. The the idea of build test fix is got convoluted over the years. It's not, in my opinion, the way I saw it at Hewlett Packard, and their products were, that was their style of design, is we have this module that's supposed to turn this light on when it does some activity. All right. Let's build
Right.
that. Let's make a breadboard of it. And does it turn on the little green light? Okay, it does. All right. Test pass. If it doesn't, why? What's the failure here and how do I fix it? And then you put that module in another system and it has more functions and you make sure those work. And or if they don't, you fix it. And it's the iterative process of, as you develop your product and from one component up to a system, up to a subsystem, to a whole pile of stuff in a box, each step of the way is you're checking your work. And we did the calculations, we did the analytics, we did the simulation, but in real life, does it work? Can we actually make it? And that was just ingrained in the psyche at Hewlett Packard when I was there, is that testing is to find failures so you learn something. It's not a confirmation that you have arrived. It's, we expect failures and we deal with them and we work on them and we solve them and then we make the product better. Whereas I've seen way too many that, like you said, is, oh, we'll do reliability when we get enough prototypes that are in manufacturing ready to go type stage. And then they take too long and we find stuff that it's too expensive to fix them. And so why did we do this? I get that too much. That's not build test fix in that regard.
No, it's just a very simple, don't have to think about it answer to what are we doing about reliability? And that's the problem.
Yeah.
Um, Whenever you have, reliability testing somewhere, all it means is that you're just waiting. Without explaining it or without having a really strong culture. And I take your point that Hewlett Packard clearly had a really strong culture when it came to this sort of stuff. But I've just seen too many times where a calendar block of time which has the word reliability in its title then makes people start to think, I should say, that their efforts for reliability only need to start that activity or someone's essentially going to do it for them. It just puts people's brains into neutral, in my
Yeah.
opinion,
Yeah.
most of
No,
the
I get
time.
that. Yeah. And I think, what Carl and I wrote about is that you don't just run a battery of tests you don't do what you did last time for any iteration of your product development cycle or stuff like that. Is you actually go talk to the design team and you go talk to the program manager and you talk to the directors and so on. And you find out what information do you need to make better decisions, and what are those key decisions that you're making that you wish you had better information related to reliability. For example, is vendor A or vendor B a better supplier for this module that has to last 10 years? Okay. Reliability engineers can solve that problem. They can create that information. Which one's better? Or will it last for 10 years? We can answer that question. And so it varies that from just being on the calendar later and some, they'll do their things over there in the lab and hopefully it all works out, to now the reliability team is running tests when necessary. Not all things need to have a test to create the information that is anticipated and wanted by the program manager or the senior engineer or whoever that needs that information to make a better decision. And so it's not that you stop thinking about it. It's early on when you're thinking about what decisions you got coming up. Oh, how can I pull in reliability to help me get better information? And I suspect that would break this not thinking about it anymore. And I don't think it'll solve it completely. There's other steps and other activities that go into it, but it connects what we're doing in the lab, if we're doing testing, back to somebody that really anticipates or needs that information. And that's a style of build test fix. Now, if we were talking to Kirk Gray, it would be, get your earliest prototypes together and let's go break them as many ways as we can in a halt sequence, and then fix them. Use that information to improve your design, but do it quickly and get results and information and good failure analysis back as soon as possible. It's another flavor of build test fix. But yeah, the one you painted, Chris, is not terribly useful for anybody.
No, and Kirk is, it's technically build something, test it, and then fix it. But with the Holt and Haas approach that he advocates, it's still aggressively trying to find ways that your thing can break.
Yep.
It's not,
I agree.
Let's do everything else and then have this final testing thing to make sure everything's fine. That's certainly not Kirk's style. And I could argue perhaps that build test fix is not analogous to Holt, because Holt is still very targeted. Even though technically you build a prototype, test it in Holt, and then fix what you find.
Yep.
Still very targeted, or should be very targeted, where you quickly build the prototypes, not of the entire system, but of the parts of the system that you keep you up at night, or you think are going to keep you up at night.
Yep. I look at reliability engineering as, if you're making something that you're never going to get a prototype of the whole system. It's some super satellite that we're only going to build one and it's going to launch. All right. So as a reliability engineer walking in and saying, oh, I need 30 samples of the full system to go do halt test or go do environmental testing. That's just not going to happen. And so we use a lot more. I'm thinking of Boeing and their wing designs. They break one wing to verify all of their modeling. So it's not the 30 samples run to failure kind of things. So I think there's an analytical approach that some teams use, and build test fix doesn't really work well in that environment when it's either too hazardous, it's too expensive, or it's just not feasible to break a prototype. You might not even have a prototype. And that's more analytics. That's more finite element analysis and modeling and all the theories of how chemistry happens with your particular product and oxidation and UV, everything else. And the other end of that extreme is the kind of Halt-Haas type stuff, is just stress it till you force it to fail, find out what margin you got. If it's not adequate, change your product, change the design. And they both have value in different circumstances. But in general, I like the idea that testing is not one of the variations, Chris, when you first brought this topic up, it was that way too many people want their product to pass testing. And so they thin out the testing so that it only can pass, because we're not even measuring whether it's working or not. I've actually seen that. It says you threw the box in this chamber at 85C, okay, and it's not turned on and you're not monitoring it. What exactly are you doing other than baking it? And, we're just going to do that for a while and hope it still works when it comes out and cools off. Okay. What does that get you? What do you know now?
I think one of the things is that that can help you work out if you're testing the right thing or not is, are you testing to, one, make sure that something does blah, 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 or two, are you testing to try and find how it can break to inform the next design iteration?
Mm-hmm.
So if you're testing to make sure of something, all right, but as a rule, when you have those, let's just test to make sure things are okay, you don't have in the schedule the 3 to 6 months worth of rework time scheduled in. It's just this I think I use the term security blanket approach, where we have reliability testing in phase 75. All right, so that's where the reliability fairy will sprinkle the dust on our product and make it reliable.
Yeah.
And it's just not quite like that.
Yeah, there's not much you can do. even if you had the fairy dust, I don't think that would help the product be different than what it is. Now, I look at testing as it's a way to uncover an area of uncertainty or reduce the uncertainty of something. Will it work in XYZ temperatures or with so much exposure to UV or a high sulfur content in a particular factory setting or something like that? And we have thought it through. We picked materials. We picked design options that we think we solved it. I'm thinking of moisture ingress for something. It's like, we think we've got it sealed up. Okay. Let's put it in a tank of water and find out. Let's put it under pressure. I think it more like a halt chamber. Is like, well, you think it's good to 1 meter. Let's check it at 10 meters. What kind of margin you got? And that's to see if your solution works. The green light comes on, kind of thing. And that's part of a natural progression for design is what I theorized and tried to assemble actually work. That's good information. It gets trickier in reliability is that, does that green light still come on 10 years after it's been in the field in this XYZ environment? Okay, well, we can figure that out. It will take time. Is that important? Do you really, really need to know that? Because it's going to cost us a bunch of money. I tend to look at it that way. It's always a trade-off. How necessary is that information for you in the program and the organization and the customer?
I think that we should also mention that there's plenty of scenarios where you just have to test to make sure things are okay, and largely because of regulatory requirements. Medical devices are a huge one where you do have to test to make sure things are okay. But the companies that do medical devices the best are the ones that don't use that as their only approach to baking reliability. They know
Right.
they've already got an amazingly reliable thing before they do the mandatory demonstration testing that the regulations demand. To the extent that the tests the regulations demand don't really add to the design whatsoever. By the time you got it to that level of testing, if you uncover a flaw, it's from a budgetary or schedule perspective catastrophic. So usually they have this done well in advance, and there are certain companies that don't, as you know, but
Mm-hmm.
it's always you can't test your way to reliability. But there are some people out there going, hey, before you guys say we can't, that testing is something we shouldn't do. The regulator says we have to, and go, that's cool. If you're relying on a regulatorily mandated test to make sure your thing is reliable, you probably have a problem regardless,
Yeah. There's a whole bunch of
whether you
problems there.
realize it or not.
Yeah. Now, yeah, I had a client recently that asked, we want your help figuring out what all the tests are that we should do. I was like, well, and they never called me back after I asked, so what information do you need that only testing can provide? And I never thought of it that way. I was like, well, it's a good step because you could do testing from here to 2050 and still not have the information you need to improve your product or know you're good enough. What do you need to know? I actually had a sales guy once, and I probably have told this story before, but it was it was a socket system with these little springy looking things on it. And you put it on the circuit board and you put your chip on top of it and it would get clamped down and that would make electrical contact with like 1,000 pins or something like that. And I said, all right, this is interesting. How does it fail? Oh, it's never failed. Really? Never, ever. It just can't be wrong. You don't mistakenly not add a pin to a slot here in your manufacturing. That would be a failure, especially if it's a critical signal pin. Oh, no, that never happens. Okay. I don't believe you. And because everything fails one way or the other. And
Yeah.
if you're not knowledgeable enough about where the limitations are of your product, it's probably not a good product. And that pretty much ended the exploration of my client with this vendor for the socket. And he just kind of got pale and left the room.
Yeah.
Having the information about how a product works or doesn't work or how does it fail or not fail is good for the design team. right off because I think that's the spot where we make a lot of, way less expensive changes to improve the product to meet our objectives or goals. Whereas the when it's in the field already, it's horribly expensive. And being up and very clear about where does it work and where does it doesn't work and what kind of stresses would be things to pay attention to is just good business all the way around. But all too often, if we're doing a build test fix, if you're working with a company or a supplier that advocates that and says, well, how does it fail? I would work with the ones that tell me, well, we found this and this and this and this and this and this, and here's what we did about those. And this one we don't know how to solve. So don't put it inside the furnace at 8,000 degrees Celsius. Okay. Versus the other one that says, oh, it's never failed. I have a real hard problem with that. It's like, oh, and then he also said, well, I asked him, did you test it? And he listed about 25 international standards of testing. And so I picked one of them out and it says, if you pass this test, what did you and the organization learn other than you pass this test? And he couldn't answer that question. He didn't know what it meant or understand why anybody would ever run that test. And I'm like, okay, I think we're done here. It's like, don't need to talk to you anymore.
Yeah, I think you want to speak to and those suppliers who are listening or people who represent suppliers. You want to be able to say, where's the effect of when Fred asked you that question or I asked you that question, or whoever asked you that question. Um, what do you want? Sorry, when you ask how will it fail, you need to say something like, well, if you use it in this scenario, we expect it to fail like this. If you use it in that scenario, we expect it to fail like that. Um, just be very knowledgeable, not just in a generic sense. You don't want to say, oh, it could be corrosion, it could be fatigue, exposed diffusion creep, it could just wear through here. We've had some explosive. You don't want to say that either. You don't want to be just a Wikipedia reference on how that particular technology can fail.
Mm-hmm.
You want to be able to say for your thing, look, when it's used like this, we expect it to eventually fail like that. And when you use it like this, it should fail in this other way, in this other
Yeah.
method. And that means that you are prepared to talk about failure, which means you know that how your thing's going to likely fail. And it actually gives you a much better chance of signing that supply contract when compared to that person who says this will never fail, don't worry about it.
Yeah. Yeah. It's like, yeah, no, I still visualize him across the table as like I was pretty fed up with him pretty quick. And my client was like, all right, I guess we're done here. But it's funny how, and I think we started off with, it's a bit of a cultural thing, is we tend to think of failures as a bad thing. And if we're designing a product for 6 months and we get it to the scheduled time for reliability testing, we're just keeping our fingers crossed, hoping it passes. Because like you said in one point, is that can really wreak havoc with your schedule and your client's delivery dates and everything else. So, or your customers' deliveries. It doesn't have to be that way. Product testing can be an iterative, ongoing thing that you are deliberately looking for where's the weaknesses? Where's the areas I need to make improvement? Does it do what it's supposed to do? Good. Right. Let's try it on a second product and maybe a third one to see if we're manufacturing it correctly, and so on and so on. The idea is that testing has to provide value. It has to provide information that somebody needs. It's not just a tick mark at the end of the program. It's really a colossal waste of time in that scenario. So and we know that the listeners of this show get this. They understand it. This makes a difference. And so hopefully a couple of the ideas and topics we brought up will give you some ways to help others understand it. And that's the key, is let's improve how we go about doing what we do so that we get better products all the way around. That's the overall goal. So if you've got a question on this for Chris or I, or for the other hosts of the show on this topic or others in reliability, let us know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. Chris and I and the other hosts are available through LinkedIn and our About pages. So we'd love to have you join the conversation and let us know what's on your mind, or comments or input or a question. We'd love all that stuff. All right, Chris. Well, so far, this test of our connection on Zoom is actually working, kind of. I have such bad bandwidth where I'm at the moment that I'm hoping that recording it comes out all right. And if not, I have a fix on the way, a new laptop. So we'll be in good shape, I hope, after that.
No worries. Well, best of luck with all of those things.
Right. Thanks, Chris. Talk to you soon.
Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.